Hello, everyone. Thank you for taking some time away from your busy day to learn about the exciting world of event management. So this is the document, and I'll share this out afterwards. It covers everything that you see here. I'm not going to cover everything, obviously, but how event management affects the organization, recommendations for periodic service review, how to help the customer accept the adoption of event management, some of the integrations, interactions, and how one would actually implement. Event management itself is, events are not actually collected by ServiceNow, and by that I mean ServiceNow is not a tool, and when I say tool, I'm using air quotes. It's not a tool to go out and actually run an agent on your endpoints, your network infrastructure. It's meant to ingest data from the endpoints, tools that a customer already has in place. So when talking about event management, customers say, well, what do I do with all the existing tools that I already have, or I invested money in them? You still use the 800 different tools that the customer has. You have to integrate them, and there's out-of-box integrations, custom integrations via API, storefronts that have integrations to give the end user, which would be your client, the ability to take those events and bring them into the instance. As you see here, there's all of these logos, all have integrations. There's always additional integrations out there every day, every couple of days. You go out to the community site, you can see a lot of customers will just create their own homegrown way to integrate, because all you're doing is actually just writing to the event management table. That's it. And the instance takes care of all of the intelligence, which I'll touch on later, with the event management piece. So integrations, not that difficult. When actually doing the implementation, and I'll share this later, it's ITOMs. I don't know how many people have actually done ITOM implementations. They could go really easy or just extremely painful. It's usually one or the exact opposite. So here's a little flow chart which I like to use. Event management, what it touches. Event management touches a lot of the different components as it relates to ITSM. There's a lot of overlap, ITOM to ITSM. So event management touches anything from service mapping to analytics, orchestration, security, anything running to the CMDB. So event management will come in and update the CMDB based on events that happen. So it will reference, event management references and updates data sets and all of these different modules. The event management, what they call a service matrix. So out of the box, there's different severities and how do they map to what an end user client has already defined in their existing. What does critical mean? This is a good chart to help relate events to what is currently deployed and how that workflow would look. Here's an example of events and how an event comes in. So an event source can be anything from any generic JSON file, SNMP. It could actually even be email. You could actually anything that would write to the table. If there's a way to get the data in, write to the events EM table. That's how an event. Once anything gets written there, a rule engine will run and will create the event. Events come in, and an event is not an alert. An event comes in, and an event would look like something to the effect of, so this right here is a lookup on the events EM table. Events will ingest anything having to do with, obviously, events and alerts, as well as metrics. So if some customers will collect metrics, which could be important to them, especially when it comes to enterprise type, Oracle type applications or something that's mission critical, they might be collecting metrics in Windows and Linux boxes. Event management has the ability to take in the metrics, take a look at the metrics, take a look at the events that come in. Based on the events that come in and the metrics, take a look at the date and timestamp, there's what they call OI, or operational intelligence, built in, which it will take a look and say, all right, every Tuesday, I'm using this as an example, every Tuesday at 3 p.m., an event comes in for this Apache cluster, all right? And at 2:45, we know based on things that we see from an event perspective, as well as the metrics that an event kicks off at 2:45, certain script runs, CPU pegs out at 90%, and at 3 o'clock it goes down. Once you start seeing these anomalies, it will actually do predictive analytics and will be able to tell you that there's a certain percentage chance that X will happen when Y occurs at this point in time. So combination with the metrics along with the event management gives you some insight into predictive analytics. So here's an example. So SolarWinds, the event would come in. The event actually looks something like this. Is an application called Postman used to post things via API. So I have a little thing right here that I'm going to post this to my instance. All it says is source, node, type, resource, event, how severe it is, and a description. So if I write this to, let's see, I believe it was my other instance. So as you can see here, this one says SolarWinds, node, Linux, type, what happened, resource, metric name. And I have something similar here. So I'm going to say that if I go to my dashboard, and this dashboard is a roll-up of all the events that are going on and how they would map to business services that have been defined. So if I wanted to emulate something like this and send in another alert, pretending that this specific CI, this server, it looks like it's a Windows server, is having some issues with the CPU, I could do that here. And node, and I'll touch on this in a couple minutes, node is the equivalent of what would be the CI name or fully qualified domain name of a server. If it is a server, that's what you would put there in that field for node. And then the CI will get looked up in the CMDB, and that's how it does the correlation, is with whatever is in node. But I'll post it anyway, and let's see what happens. Oh wait, description. All right, so it just sent the event. So this is the one I just sent in. It didn't group it. So usually what happens is a good example here. So what a lot of customers like about event management is rolling everything up into a single dashboard. So what event management has the ability to do is it will do correlation. So it will correlate based on if it sees a lot of very similar things going on or affecting a CI in a short period of time. So even if it's from different sources, if it affects the same CI or same business service, what will happen is it will actually group them together. So you can see and get to the root cause a lot quicker. So when a CI event comes in and you need to alert somebody, there are rules that are put in place which get run. So when an event comes in, it's going to take a look and see what CI is affected. Once it sees which CI is affected based on information that it has from your CMDB as it relates to relationships, so discovery or service mapping, and it knows what services are connected or defined by that service, what they're running on, what the application is talking to, basically what everything relies on. So if your services are mapped, what you can do, or even if you have like a manual business service that is mapped, so you have manually defined relationships. If you have the relationships defined, it's going to show you what is affected. So if you have a service map and you click on that service map, any component that makes up that business service, if it has been affected by an event, if there's alerts, outages, changes, so any type of changes that are going on, root cause, if there's actually an anomaly or issue going on, you could actually click on the CI. And if there is an impact to anything beneath that, it will actually show in the root cause CI. This tells you that there's a very good chance that what's causing this issue is that specific configuration item. That is a, the service map view, exactly what you see. You can see the alerts, impact, changes. So this is nice, especially when it comes to event management, because you can actually go back in time across the top from left to right in any one of these maps. This is like TiVo. So this is a timeline. So I have it set to months. So this is a month's worth of time. And red is obviously bad. Green is good. And of course here, I didn't reset the date and time either. But what you can do is actually go back in time, and it will, if anything is changing the environment, so if an event had just occurred, you could actually go and rewind and see what had happened. You could go back and see, all right, an alert happened here, but it was green at a different point in time. You could actually do a comparison, but I don't have anything green right now, else that would be great. You could actually do a comparison and say, all right, what's different between these 2 points in time? And it will do a compare on date and timestamps of what happened to that CI. Compare that to what was written in the events table, and then show you exactly what had happened. Here's the differences, here's what had changed. And it's very good, especially when if your change management is good or not good. This gives you some added insight. So if something had happened over the weekend, nobody documented it, you could see, all right, well, last week, everything was fine for the last month. All of a sudden, starting on Sunday, the server farm started acting wonky. Why is that? You can actually go back and see. So you're comparing the CIs themselves. So if I was to, I would compare this business service, customer management, and take a look and say, all right, what alerts or changes to every one of these CIs it has happened recently or is planning on changing at this point in time. It's like a date and time stamp. Compare that to the state of those CIs on whenever it was. So on the 11th of last month, for example.
So it's looking at basically you're comparing 2 points in time, and it's showing you the alerts that happened during that time frame, as well as any change records. But it's not actually looking at like the discovery results of that particular CI to compare.
No. Yeah, no.
Okay.
Yeah, it's not going as deep as like take a look at the discovery log.
Okay.
And see what has changed. It's just the state of active alerts, incidents.
Just helps you narrow down. Hey, we did a change. We had an approved change at this period of time that might have caused this problem.
Yep. And if you have metrics,
okay,
which might be calculated or collected, you could actually take a look and apply the metrics here too. See how it has it. So you could say, all right, boom, I want to take a look at this date and time something happened, and you start dragging the metrics that are being captured of those actual CIs. So it gives you more insight into what's going on underneath the covers. And you could tie that even further into if it's actually discovery, you could take a look and see what processes are running with discovery. So when discovery was running, or when this CI was discovered, here's the running processes. So you could actually see the processes, the PIDs, correlate that with CPU, correlate that to events, and you could actually pinpoint what had happened pretty quick. The trick is getting there and helping the customer get to the point where they can make sense of all the different tools that they have in place. And usually, the best way to do that is to start ingesting all of the alerts, or events. So when you take an event in, so event rules are exactly that. The rules that are applied to events when they come in. And when you're a net new deployment, what you want to do is ingest, work with the customer, figure out which ones potentially could be important. Once they start getting ingested, it will actually start making recommended rules based on the information that's coming in. It will say, hey, as you can see here, hey, take a look at this. We see 4 of those, 29 with this that look like this. Maybe you should make a rule. So you can say, all right, let's do that. let's make a rule. The rules are really easy to make. It's what do you want to name it? And we will call it test. Perfect. Source. So what is the source going to be? And what order do you want to run the rule in? So you could do nested rules if you would like, which are very helpful. Event filter. So these are populated based on the recommendation that the instance gave me. Said, all right, description will meet regex. This, it's actually over here, is a really nice regex GUI. So you don't even need regex. So you could actually create some rules without regex. You could actually just highlight, click on whatever you want that selection to be named as a variable, and then it'll do the regex for you and say, all right, capture this. Here's this string, has to match this, but in this section, I want to capture the name of the server. You could actually just highlight it and it'll write the regex for you. So you just create the filter, has to match these components. We don't obviously need it to be this granular. Resources mid servers and metric name is this. And if we want to transform it, this is where you do your transformation. So when it's, especially when you're doing your own custom or third party, you're going to want to match the fields, and it can be done here. A lot of these are pre-populated because, again, it just uses the existing rules that it's recommending. And then this is where you would put your threshold. So this is where you would apply your filters to filter out a bunch of your junk. So this is where you could say, I want to filter out this one endpoint from this one source because 99% of the time it's just flapping and throwing me junk. So you can say, all right, I'm going to filter out the junk and I'm going to make this active. But once it hits that 100th time in 2 minutes, then I want it to alert me. And then this is the binding, which I alluded to earlier when I was referring to the node, the name of that field called node. That node is what it uses to map to the DNS name of the server or endpoint. This is where you would define how it figures out what you're talking about in the CMDB. This is a binding piece. And then you would hit save. There's my rule. What I'll recommend is if they don't have them put in place is, threshold alerts for, CPU, memory, network connections down. Sometimes they'll have, customers will have agents which will do monitoring of their web portals. So it will ensure that their web portal's responding in a timely fashion, along with latency. So I help them create those rules, which will use those threshold triggers. Say, all right, if I get these types of responses in this many minutes with this count, whether it's page refresh is over 20 milliseconds, those basic ones are usually the ones I help them set up. When you initially go out to deploy events, working with the customer just to figure out what's noise. So that goes back to the whole threshold piece where just help them mitigate a lot of the noise and work with them on the hardware events. So anything that happens, something that happens frequently and something they have a process for, implement those first because that gives you low-hanging fruit, some quick wins. Deploy those. They learn how to action upon them. They know how to use the system, teaches them how to use the instance, and then move forward with the whole change, whether or not node's up or down, and then go into the those metrics with the performance thresholds. Alert correlation rules. So you could actually create alert correlation rules that are not out of the box, but a lot of the times, if you take a look at all of the alerts, the instance itself will actually group based on severity. So severity has to be the same. Sources will be different. Node or application would be the same, depending on what it is, if it's an application. So if it really doesn't have a CI mapped to it, but it has components of a CI underneath it, so a business service, in that case would be the same. And then underneath it, what it'll do is it will actually draw the correlation. So if you take a look at, oh yeah, here's another thing too. This is where it gets a little confusing, is there is I still, to be honest with you, still have to completely figure this out, is root cause analysis configuration. So this is where it actually does all of the intelligence and will try to determine root cause analysis with some algorithm behind the scenes, and it basically chunks all this information and then comes up with the root cause. And this work goes into the historical analytics and will make recommendations. Like I said, to be honest with you, I don't know a ton about the root cause, but RCA, that's what the root cause analysis does. Other than that, I don't have a lot about the configuration behind the scenes. I don't know exactly how that's configured.
Event rules is really just about translating data coming in from the outside into the record that gets put into the actual event table.
Yes.
And maybe weeding out, if your bot is spamming you, here's 1,000 of the exact same rule over the course of 2 minutes. Well, we only need one, so only put one event in the table. What handles whether or not those events across multiple sources become one alert or more than one alert is a separate type of rule, and that's the alert correlation rule.
Correct. If you take a look at the events, here's events that came in. An event comes in, it gets processed. The process itself, it'll tell you how that event came in and the process that went through to see if there are any rules applied to it. So this node will be resolved. CI type is empty. You can actually create an event sample or check the processing. So if you're trying to figure out, all right, I'm trying to create this rule and I can't figure out why it's not binding to the CI, you could actually see here, why it's not processing, create a net new rule, create a sample. But the whole point of me showing you this is there's events come in, it gets run through a couple different engines, tries to figure out what to do with it and whatever. This is the actual flow of what happens when that comes in. It's, is there a rule? There's no rule. It's just going to write it to the event and transforms it, figures out the threshold, maps it, tries to figure out what CI, create a net new alert, or updating existing. That's it. So I believe I showed you guys the alerts console. So the alerts console is, as I showed you earlier, I kind of showed you this, this is all the alerts that came in, right? And the node. So the alerts console is a kind of think about it as the all alerts view, but kind of rolled up into something a little bit more intelligent. So it will actually show you things that have been correlated or grouped together. Kind of like what you and I were just talking about, is it will take these and group them, as you see here, group alert. If you expand it, it will show you different sources, SCOM and Nagios, but still it's all under one alert because CPU sees an issue with memory, storage capacity, something's going on. So it just kind of grouped it up and said, hey, you got something going on here. This is a roll up. It'll show you the group alerts, whether or not it's correlated. You could actually see a time frame. Unfortunately, I don't have a lot of data in here, but this would show you how the instance keeps track of everything. You see the different alerts, even if it's from different sources to the same CI in a specific time frame. Once you start seeing all those patterns here, that's where it kind of gives you some insight into some of the intelligence that's going on behind the scenes to make recommendations. Well, that's all I had, and I appreciate the time. Thanks, everyone.